We will graph this polynomial function in stages. So we're going to look at a very simple graph first and then add complexity one layer at a time. So the first graph we want to look at is the graph of y equal x cubed. That's going to be the basis for what we're going to do. And if we were to plot some points, we would see that y equal x cubed basically is a graph that looks like this. We should become familiar with these basic polynomial graphs. The next thing we want to do is look at y equals 2x cubed, and I'll make that graph dotted. So the difference between this new graph and the old one is the new graph, the y values are twice as much as the old y values. So the new function is going to be basically twice as high. And we're just drawing a rough sketch here. So the y values are approximately twice as high, so it's a little bit steeper. The next thing we want to do is see what y equals negative 2x cubed looks like. And the effect of the negative sign says take the dotted graph and flip it over the x-axis. The y values are the negatives of what they used to be. So this graph is going to look like this. It's the dotted graph flipped over. Now I want to see the effect of the negative 3, and what it tells us to do is take the last graph we had and slide it down 3 units. So the point that used to be at the origin now is down 3 units, so it's going to be right here. The rest of the graph, every point has been slid down 3 units. So if we just plot a couple points, if x were to be negative 1, x cubed is negative 1, negative 2 times negative 1 is positive 2, minus 3 is negative 1. So we're going to get a point somewhere around here, and the rest of the graph is going to look something like this. So what we've done is basically taken the last graph here and slid it down. We should try and find out the coordinates of this intercept, but that's a little bit difficult to do, but we could certainly do it.